The other one is inferential statistics. Now, when you say inferential statistics, so that means we are, drawing conclusion about the population. Okay, and population is unknown, isn't it? Mostly population is unknown. We don't know. But how do you? But we want to study. We want to understand the population. So how do we understand the population? So that is mainly by taking a sample, and then the process that we make decisions about population is known as inferential statistics. Okay, so that's what we are going to do today. So there are different ways of doing inferential statistics. So one is hypothesis testing. So first, if you open the slides, you know where you find the slides, right? So this one. So that is hypothesis testing. Yeah. So in hypothesis testing, we are going to test whether a particular certain belief, a certain statement is true or false. Okay. So if you say a statement, someone can say something about the population, right? Because population is unknown. Okay. So we always, based on certain things, we actually write or talk about, then we believe certain things, right? So we believe there's life in Mars, there's water in Mars. It's a sometimes ago it's a belief. We still think, we are still not sure sometimes, right? So how do you verify whether it is true or false? Right? So how do you verify whether it is true or false? Well, that's about mass. But this is actually about the population, within us. Now, we can write a sentence, and we can, we believe certain things. But you can actually test whether this is true or false using statistics. So that is called inferential statistics. Okay. Now, in this course, we only limit our hypothesis testing for population mean as well as population proportion. Those are the only two things that we actually do in inferential statistics in this course. Okay. What are the two? Population mean and population proportion. So in other words, so please listen carefully. If we should be able to verify any statement, related to population mean or related to population proportion, once you've done this course, okay. But there are other parameters, right? The population standard deviation. So that is also a parameter. We don't go beyond these two, but you can expand if you want to study them later. Okay. So now, can you give me? All right. Let's take an example. So example about population mean. Can you give me an example about the population mean? Say Griffith College students. That's a population, right? So something about the mean of them. Suppose that Griffith College students' mean age is 25 years. So that is a statement, right? Mean age is 25 years. That is a belief. We don't know whether it is true or false. Okay, so that means Okay, so that means mu, that's a population mean, equals 25. So that is a belief. All right, somebody can say that. Any other example? Okay, so examples, Griffith students mean age is 25 years. Another example about the proportion. All right, say start with the mean. We can say that Queensland average savings is $200 per week. That's a statement. Can you give me another example? Any statement related to means? Who want to say something about another statement?
The number of international students equal this university.
Sorry?
The number of international students equal this university.
Yeah, so number of international students
Equal this.
equals to
Equal this. Equal this university.
you said a number, right?
No number.
No number. So if you don't have a number, we can't test. Right? That's a very very good. Yeah, very good that you bring that. So if somebody says that my favorite color is blue, I mean you can't test that. You know. But your example, we can put it like this: proportion, like 75% are international students. Okay, so this is a proportion. You can see there is a number. So this is not the mean. This is a proportion. So 25% are domestic students, 75 are international students, right? So these are all hypotheses. I mean this just came to our mind, and we don't know whether they are true or false, right? You can say it's, no, not 25, it's 20. That's another hypothesis. No one knows. Okay. Someone can say Queensland's average savings per week is not 200, 250. That's another value. I mean, no problem. You can test anyway. You can see now, right? So these are the first two are about the population mean. The last one is about proportion. Another example for proportion. So can somebody bring another example? Um, 80% of all Australians what 80% of all Australians what got COVID vaccine. Australians are vaccinated against COVID. Okay, so now these are all hypotheses, so we should be able to test. Any questions? Okay, so this is another example. Yeah, suppose firm manufactures agricultural products, you know, so they produce fertilizers, right? So they produce fertilizers. Suppose they are going to produce a new fertilizer. Why do they produce a new fertilizer? If you're a statistician, how do you think about it? Yeah. I mean, it's a generally it's a simple thing. You know, they produce a new fertilizer. So if you are a statistician, how do you think about it? They produce a new fertilizer because existing fertilizers are having some issues, right? So they produce a new fertilizer because new fertilizer is going to increase the crop yield. That's what they believe. So if you are a statistician, you should be able to believe, verify this belief, whether the new fertilizer increase the crop yield or not. That means the mean crop yield, right? Mean crop yield. So how do you, yeah, that's another example. This is another example. A company has developed a new product. So whenever we produce a new product, how do we know whether it is profitable or not? You know, how do you know? You know, they do a market analysis, right? So they believe if 10% of potential customers buy this product, it is going to be profitable. So 10% means it's about proportion. It's not mean, it is a proportion. So we have, you know, we have different values in statistics or in our analysis. We have, you know, proportions, like we have proportions, we have ratios, isn't it? So there are different values. So interest rate is a percentage, right? Weight means it's a number, it's not a percentage, you know. So we use all the numbers and percentages. This is another example, quality control, right? So in this case, engineer will is believing that, so engineer, he believes that firm's products are defective but very small percentage. So that is also proportion, right? Suppose that if you make 100, only 5% are defective. Defective means there is a damage or faulty in the production. So these are the areas that we use hypothesis testing. Now, hypothesis testing is actually used in all kind of fields. It's medicine, it is engineering, economics, policy making level, all these subjects, right? I mean, those are actually subjects, concepts and procedures that are actually used in the outside the class. You know, if it is a hospital, it can be a company, or it can be another organization, it can be government organizations. These things are happening, you know. But, you know, I don't think that they have developed these theories to teach students, you know. The purpose is actually to benefit these things for humans. Like if they manufacture a car, right? When they manufacture a car for the first time, that is not to teach them how to manufacture at a university, but it is for human development, right? But you know, we have bring them into classroom. So therefore, hypothesis testing is not for just only for teaching and learning. It is actually for you know, to be used in policy making level, because in order to make decisions, we can make decisions based on hypothesis testing. Okay. Okay, so this is actually how you do. So there are 6 steps you have to follow. First one is that you need to set up the null hypothesis and the alternative hypothesis. Okay, so we in statistics we call null hypothesis. So that is the one that we are going to test. Okay, so null is called H naught, right? H naught is the null hypothesis, and then we have to have an alternative hypothesis. You know, null is actually based on the statement, right? So the statement is true, or it can be false. If it is true, alright, we accept it as a true statement. If it is not true, what are we going to accept? You know, if it is not true, we have another hypothesis. So therefore we have two hypotheses. One is true, the other one is not true. Okay, so we don't know. So we need to verify this null hypothesis using statistics. So that is step 1, setting up the null and the alternative. Okay, so we have discussed 4 different hypotheses, right? So how do you set up the null here? The first one, yeah, so the first one, our null hypothesis we write called H naught, right? H naught, here the mu equals 25. So that is the null hypothesis. What is the alternative hypothesis? Give me an example for the alternative based on this one. Alternative. Alternative. HA means alternative. Mu equals 25. What is the alternative? It can be either bigger than 25. Isn't it an alternative? 25. If it is not, it should be bigger. What else? Give me another one.
Smaller than 20.
Sorry?
Smaller than 20.
Smaller than 25, very good. Another one. It is not different. It is different to 25. So that means these are the 3 different alternative hypotheses. You can't have all. You can test only one against the other. So if you look at this one, Queensland residents, their savings is 250. So that means our alternative hypothesis is mu, mean value 25, 250, right? Alternative is mu equals a mu is bigger than 250, right? Less than 250. So anything like that. So I hope it is clear. So that is the first one, or setting up alternative and the null. Second step is, you calculate your Z statistics. We learned how to calculate Z statistics last week. Week 6, right? We did this one, week 6. So Z statistics means we have to have a Z statistic related to our hypothesis value, right? So you can't test a value without converting it. So we convert that into a Z value. So what do we have here? Sample mean. So therefore we have to have a sample. So based on that sample we have the mean. This is our null hypothesis. So the value that we actually assume or believe. And this is population standard deviation. Simple n is called what? What is simple n? Yeah?
The natural number.
Sorry?
The natural
it has a meaning, and we discussed what is simple n, is sample size. Alright, it's sample size. Now here, this is the population standard deviation. If you don't have population standard deviation, you have to use sample standard deviation, right? If you are using sample standard deviation, this distribution does not follow Z distribution, so it will follow a different distribution that is called T distribution. I think I hope you can understand that population standard deviation is not there actually. Alright, we don't have most of the time. If you have, that's fine. If you don't have, then you cannot stop. You should proceed with sample statistics. Okay, is that clear? Yeah, so you need to choose what formula you're going to use in step 2. Step 3 is, step 2, if you are using proportion, use this formula always. But if you are testing your mean value, you can use either Z or T. But if you have population standard deviation, you have to use Z, otherwise you're using T. Then step 3 I'll discuss later. Step 4 is actually you define the decision rule. That is, you're defining a rule how you're going to make a decision. That means decision regarding, whether you are rejecting the null or you are not rejecting the null. So you set up a decision rule. So this is a decision rule. So the decision rule always depend on alternative hypothesis. Okay, suppose that here this one. So there are 3 different alternative hypotheses. So 1, 2, 3. So your decision rule depends on which alternative hypothesis that you are using. Okay. So therefore, here, please remember the decision rule. So two-tailed test. This is the decision rule. If it is right tail test, this is the decision rule. Left tail test, this is the decision rule. And then you make the decision, calculate Z value, and then you are going to make the decision. So that's what we are going to do. So let's do this using an example. Yeah. So I'll tell you how to do this quite easily. Now, first you can draw your Z distribution. You remember this is our Z distribution that we discussed last week 6, and in this Z distribution there are two. If it is a two-tail test, right? So two-tail test. That means you can have this side as well as this side, and there is a critical value. Suppose it's 1.96, negative 1.96. This is positive 1.96 because they are symmetric. Okay, so this is critical values, and then this side is called so that's your left and the right. So this is called H0 rejection region. So if your critical value is 1.96, and this is called rejection region. This is also H0 rejection. Okay, and in the middle, this is called H0 acceptance region. Okay, acceptance region. So to your left hand side from 196 and your right hand side from 196, you in either case you reject H0. How do you decide that? That is how you have to find your Z value. So how do you find Z value? Z value is x bar minus mu sigma divided by n square root. So if this value fall into this area, we don't reject H0 because it is called H0 acceptance region. If this Z value falling outside, that means either here, this area, or this area, we reject H0. Okay, so that's how you make the decision. Suppose that suppose that your Z value is 2.5. 2.5 means it is falling into rejection region, then you actually reject the null hypothesis, right? Suppose that you get smaller value, like Z value is 1.5. 1.5 means it is falling inside. So 1.5 is somewhere here. So that means H0 accept, right? H0 acceptance region. So that is basically how you make the decision. So we have some applications. So this is our first one. You can see that. Now you have to start working. So can you work on this? So follow step 1, 2, 3, 4. See whether you can work out that question. So the factory supplies parts for motorcycles. So they produce engine part. So it has to be 6 centimeters. The diameter has to be 6 centimeters. Now the quality control manager, he believes there is a faulty. Okay, what do you mean by faulty? Huh?
It's an error.
Yeah. What when you say error? What about what numbers? So anyway, the manager he believes that there is an error. Okay, faulty in the machine. So the faulty means they are not actually doing the correct size. Right? There's a faulty. Now they want to test whether this is true or false. So in order to test whether this is true or false, they take a sample of 40. Right? Sample is 40. They take a sample of 40. So what did they get from the sample? See whether you understand. Yeah, do you know what they actually found? So they found sample mean, how much? 5.9, and standard deviation from the population is 0.26. So based on this information, you have to conduct the hypothesis testing. So try whether you can do it or not. I know most of you are like thinking, oh, why should we learn this piece or whatever. That's what you think, right?
No, not at all.
But I know few of you know think so, but I can't change their mind. So if you're happy, just keep on doing and try and do it. I know if learning is hard sometimes, it's not really what you want to do in the class. So try. So the first question, now first thing actually, when you look at this, you know, this is your statement. You know this statement is actually, if you are a statistician, that is your job is actually to understand the question as a statistician. But other people are not statistician. You know, they are from different areas, right? So this sentence is called the manager. Sorry, the part of this product should be 6 centimeters. All right, they say it should be 6, right? But the manager think it is not actually producing that 6 centimeter diameter product. So as a statistician, how do you know? I mean, this one anybody can understand. I mean, anybody can say, oh, if it is not 6, it has to be 6. But there is a faulty, therefore the diameter is not 6. So as a statistician, how you take it? Alright, so as a statistician, you need to set the null and the alternative. Okay, so this is how you do it. Your null is say 6, your alternative is not equal to 6. Okay, not equal to 6. Right? Is that right? So what do you mean by equal to 6? Can you say it in other words? 6 means what? You know, in English, plain English, what do you mean by 6? That means machine is working properly, isn't it? Right? So that you always have to move from one statistician to a general public. You know, not everybody can understand. If you say mu equals 6, what do you mean by that? So you should actually put them into layman language. Okay? This one, that means if it is how do you write this one? Machine is not working properly. You know why? Because if the engine part has to be exactly 6 centimeters in diameters, right? I mean, exactly fit onto 6. But if it is bigger than that or smaller than that, it is a faulty. So that is why we have to write our null alternative hypothesis using our common sense, right? If the machine is working properly, it should fit the engine part. If it is smaller or bigger, it is not fitting properly. Okay, yeah.
So even if it's like 0.01, it's still
Yeah.
not correct?
it has to be 6 average. Okay. It's different, statistically different. Okay, so we have to use our common sense. I mean, when you are doing a subject, it is not always that subject. It is always, it is also part of our thinking capacity. You know, how much common sense that we have, how much logical we have, or if not, how you going to improve. Okay, so if the machine is working, it should be 6. If it is not working, it's be either it can be either below or more than 6. Okay. So that is your first step. Okay. So this is actually your third question, last question in your assignment. So the last question in your assignment is hypothesis testing. So each one you have to write your null and alternative by looking at the question. And then you have to calculate Z value. Okay, Z value. So this is also known as test statistic. Okay, so this one is called test statistic. See this one? So they use this word test statistic. Test statistic. So this is called test statistic. Okay, so that's called test statistic. So in the test statistic, so you can calculate it. Yeah. Do you know how much is that? Can you calculate? So you need X bar. So X bar, how much?
40.
No, 40 is sample size. This is called mean diameter is 5.9. Okay, so X bar is 5.9. So X bar is 5.9. Okay, so what is mu naught? Mu naught is actually the hypothesis value, 6 centimeters. So that is mu naught. 6. Oops. Mu equals 6. Do we have some population standard deviation sigma?
Yeah, 0.26.
0.26,
6.
yeah. Because it says, yeah, standard deviation is 0.26. And then we have n, simple n is sample size 40. So this is sample size 40. I think that's more that's clear, because for this formula you have all the 4 numbers. So then let's put it them here. 5.9, mu is 6, right? And then sigma is 0.26 divided by n square root, which is 40. So how much is the answer? What is the answer? Yeah, you can use your calculator. So if can't actually straight away get the answer. I know sometimes you struggle. This is not statistics. I mean, how to calculate it. It's not statistics. It's mathematics. So 5.9 minus 6 divided by 0.26 over 40 square root. You know, sometimes you might not, you can't, if you don't know how to do it first, like 5.9 minus 1 is called 0.1, right? Minus 0.1, is that right? Yeah, and then 0.26, how much is the square root of 40? Six point 32. Is that correct? Everyone got the answer? Yeah. Also remember that I mean, I don't know whether you're using calculator or Excel. If it is calculator, 40, there's a button here. This is, yeah, so it's 6.32. Yeah, let's say 6 decimal. Because this hypothesis testing can be very crucial. Sometimes even if you have 0.01, you might reject null, or if it is little bit different, you might not reject. Okay, so we have to be careful. I think that's it. Um, 0.26 divided by 6.326, so it's 0.1, 0.0411. Yeah, so 0.1. 2.43 minus 2.43. Okay, so that's the answer. So minus 2.43. That's a test statistic. Okay, so that is step 2 done. Step 3, I'll tell you why 3 is important. Now go to the rule. The rule is you reject H0 if your test statistic is bigger than the critical value. This is test statistic, right? 2.43. So you already found that. You actually reject your null hypothesis if test statistic is bigger critical value. Alright? You also reject H0 if your test statistic is less than negative critical value. That's it. So that's all about hypothesis testing. So now you have to find the critical value. So critical value means, you know, in the distribution. So critical value means, you know, this distribution, Z distribution, that you know, we have to make decision at different alpha. So if alpha is If it is a two-tail test, you need to divide alpha by 2. So therefore one side is 2.5%. So therefore this is 2.5%. So this is 2.5%. So this is your critical value minus 1.96 or plus 1.96. So you only have to use 3 different critical values. So you can remember that. One is 1.96, other one is 1.645. So we make decision at 5%, 10% or 2.5% or 1%, right? So those 3 values. So 1.96. So your critical value is 1.96 or minus or plus because it's two-tailed. Now can you make the decision? So your critical value is you have 2 critical values, okay? One is 1.96, other one is minus 1.96. So what is your conclusion? Is there anything true here? So you have critical value. Right? 1.96, that's your critical value. So it is either plus or minus. Right? And then you have test statistics. So what is the test statistic? So test statistic equals minus 2.43. So can you compare which one is bigger? So reject if Z value is bigger than critical value. Is it true? Is it true? Question is minus 2.43. Is it bigger than 1.96? Is it true or not?
Not true.
Not true, yeah, because it's positive, so it's not true. So therefore, reject if Z static is bigger. So therefore, this is not happening. So that means in the first test, you can't reject. Then go to the next one. What is the next one? Next one is minus 2.43 is less than minus 1.96. Is it correct?
Yeah.
Yeah. So that is correct. So that means reject either case. So that means we reject. Therefore, our conclusion is reject H0 because minus 2.43 is less than minus 1.96. Okay, so therefore we have to compare finally 2 values, critical value and the test statistics. I think in mathematics, if you remember, so minus 5 and minus 2, which one is larger?
Minus 2.
Minus 2, yeah. So if you remember that, that should be, it's not going to be a problem. So when you compare 2 minuses, that's how it works. But of course, you know, 5 is bigger than 2. Yeah, that's all about my hypothesis testing. So statistics is like you have to do a lot of practice. Okay, now you you can do it manually or you can do it using Excel. I think in your assignment you have to do it in Excel. Okay, so you know you have an Excel template, so I'll give you that too now. So you only have to put these numbers. Put the sample mean here, put population standard deviation here, enter your sample size, what is your hypothesis value, enter, and they ask what is alpha. And then Excel will give you Z statistics. Compare this one, and then you compare this one with the critical value. When you compare these two, you know whether you are going to reject or not. That's all you have to do. Yeah, if you actually go to your this one, week 7, you scroll down week 7. There's something called hypothesis testing Excel template. Can you please open that? So there's a Z formula. So here is called sample mean. Can you enter sample mean? We got 5.9, right? And then population standard deviation 0.26, sample size 40, hypothesis mean 6, alpha is 0.05. So you got these numbers. So 2.43, because it's less than minus 1.96, you reject the null hypothesis. You know, this one won't tell you whether minus or positive, so you can assume it. Okay, now, so in the you can try it, that's fine. Yeah, any problem, any question? Okay. So I changed this question a little bit. So can you work on the new question? See whether what is your decision? Can you tell me? Yeah, you can discuss with your group or with your friends. Okay, so did you manage? You need any help? Any questions?
Yes, for help.
So I'm still stuck with the original of like the error.
You don't have to touch that side. You just need to. What happened?
Oh, I just put the numbers down
Yeah.
and then
You don't get any values.
yeah. So like, how did you get the value again?
You just put the numbers. It automatic.
Oh, okay.
You can close it. Close it
Okay.
and open from the web.
Oh, open the web.
Yeah. Big 7. Last one. Yeah. Is that where you got it? Yeah. Now
Oh.
put those numbers.
Oh, okay, sure. That's true.
Now sample means 5.9.
What is it? How much is it?
6.
6 and alpha is
0.05 into I don't know what you are doing. Don't do anything with that. Don't touch.
But it's supposed to automatically.
Yeah. Can you close it and open again?
Sure. Should I save it?
No, just close.
Okay. And then reopen it?
Yeah.
Okay.
Double click. No, open from the web.
Open from the
Yeah.
web. Like for some reason I just
Yeah.
download.
So let me try. Yeah, just enable editing. Okay, now type.
Okay.
No, why you double click?
Oh, just type.
Yeah, just type.
Okay.
5.9. Enter. Yeah, this is population standard deviation 0.26. Enter. Sample size is 40. Mean is 6. Yeah. Yeah. Enter. You are getting values. Yeah, it's quite mysterious. I don't know what's going on.
So now I can ask AI later. That's fine.
Okay, all are you all okay? Okay. You get this formula? It's in week 6. You got it? Yeah. Yeah, anyone having problems? You download the Excel, right? It's in week 7. If you scroll down to the bottom of the page. Yeah. Only it's not working for you. I don't know why. You know, can you go to the Excel and see the same Excel? Yeah, you know, go to the other page. Yeah, put some numbers.
Sure. Oh, just
Yeah, put 6, same thing, 6.
enter.
Yes, 2, let's do, yeah. Yeah, you can put. Yeah.
6.
Yeah, I think it's problem with your Excel.
Like here's 2 more.
Yeah.
And then pilot.
A3 yeah. Okay, I think I know what's happening. This is 5.9. Yeah, yeah, I can't find it. There shouldn't be a problem, but it works everybody. So what did you find here? Yeah, anyone found the answer? Yeah,
I have a question.
yeah.
Where is the Excel there?
If you go to week 7, if you scroll down to the bottom, so the last one is Excel sheet. Yeah, what is your conclusion? Sample mean is 5.95, right? I mean, I'm talking about this question, this month, this question. So 5.9, so that's a sample size. What is population standard deviation? 0.3. What about sample size is 40, hypothesis mean is 6, alpha is 0.05. So what is your conclusion now? Because your set stat has changed. Your critical value never changed, you know, it's 5% means in the standard deviation, standard distribution is always 5% is 1.96. It never changed. Only thing changed here is your this never changed. This is the only thing changed. Okay, so it has changed. Z statistic has changed. So what is your conclusion? Yeah, you can do it like this. So go to the distribution. So the distribution has an area, H naught acceptance and rejection. Your critical value is how much? Always this 1.96, 1.96. That never change. Only thing is Z statistic, right? That's the one change. How much is Z stat? Minus 1.5. So minus 1.5 is, give me a second, minus 1.96 here. So the critical value is that. So your Z statistic is minus 1.05. So that means it is falling in the H naught acceptance region. So that means you accept H naught. Okay? That means you need to look at the rule. Reject, reject H naught. Test statistic is bigger than Z value or less than your Z value, minus value. So that is not fulfilling. So therefore, we cannot reject H naught. Yeah, what's the question?
Where is except for this one?
You go to week 7.
Except for this one.
Yeah, scroll down. Scroll down.
Scroll down.
Down. Further down. Yeah, the last one.
This one?
Yeah.
For except
Yeah.
this one.
Yes.
How to do that? That's value.
You need to read the question and you need to find out those values.
When is question? Question is
Yeah.
Orientation thing, you can see this one in the backpack, the backpack, output, and this one.
Okay.
where is question? For that. I'm looking for question.
Questions are in. If you go to week 7. Before class type, can you look? I'm going to show you. Look at this one, and then you download the slides here.
Before class.
Yeah, before class.
Yeah,
So that's we do this before class. So there are learning content slide, and then look at the last, the last PowerPoint slide, application example step by step. Open that. So it has questions.
So written by a university student.
Sorry.
That one?
Is it PowerPoint slide?
It's upload. On this table one.
Have you opened this one? Okay, so shall we do one more example? So this example I'm going to create now. Students So can you do this question? Yeah. Okay, so when you do this question, your first thing is you setting up H naught. So what is H naught you're going to do? Mu is 20. That is your H naught, right? What about H1 or HA? What is alternative hypothesis you want to have? Mu? Let's have it not equals 20, easy, right? So if this is accepted, Dean is correct. If it is not accepted, Dean is not correct. That's it. So can you see whether you're going to accept a null or you're not? Yeah, so how do you test? So I hope someone can try it and let me know what is your conclusion. Yeah, so what is the test statistic you got? Huh? Anybody? Yeah, anyone? Did you get it? How much? -1? Okay. Anyone got -1?
Yeah.
Okay. So if you got -1, what is your conclusion? You reject null or you're not?
No reject.
Don't reject? Yeah, that's right. Very good. So let's do, I mean, if you couldn't follow, this is how you do. So sample mean is 19. If you read the question, sample mean is 19. Standard deviation is 10, because you can see it's given here. Sample size is 100. Hypothesize mean is 20, because that's the dean says. 0.05 is alpha. So it's -1. That's your z value. So now I think everybody can calculate this value. I think you have a problem of whether reject null or you're not rejecting the null. So that is the problem, right? So in that case, you have to draw the graph. I mean, you can draw this. Right, so this is 1.96, this is -1.96, so your z value is here -1, so this is rejection, don't reject, so this is area called do not reject H0. So if it is falling into this area, your z value, that means your conclusion is do not reject H0. So is D correct or not? So is D correct?
Correct.
Huh?
That's correct.
Correct, yeah, because H0 says mean is 20, that is what Dean says. So the Dean statement is correct. So that's the conclusion. Okay, now question number 2. Can you do that too? Question number 2. Okay, in the question number 2, yeah, help me. Do you have the mean? Do you have X bar? Do you have simple n? Do you have population standard deviation? Can you find out how much is mu? Yes, mu. Now, mu is, I said this is actually a statement done by, okay, someone who has no idea about statistics, right? So we should, as a statistician, our responsibility is put that into statistical statement. So by this, looking at this, what is the mean? Mu. Mean,
400 or
400. Yeah, that's right. Because this is what they believe. Real estate office believe it's 400. Right? Less than 400. Okay? So it's 400. So what is X bar?
385.
385, yes. Because that is a sample mean, because they said they got mean sample is, sample rent is 385 based on these samples. Sample size how much? 96, because it says they got a random sample 96 rent properties. What about this one?
What?
Do we have?
Is that deviation?
Huh?
Is that standard deviation?
Yeah, yeah, do we have it?
Yeah.
No, we don't have population standard deviation. We have sample standard deviation 100. Yeah, because if you look at the last sentence, that's you. This is just, English, right? So it says standard deviation is 100, but that is based on the sample. So you don't know the population standard deviation. Okay? Because you should be able to sort out any problem because you are a statistician, right? It's like, a lawyer or a doctor. You can't say, oh, I don't know about heart, so please go to another one. If you say, I don't know about kidneys because I haven't learned kidneys. So it's not like that. So you're a statistician, you should be able to handle when you have population standard deviation and when you don't know it, right? So the actual world is more complex. Yeah.
Can I ask again, what's the 100 again?
100.
It's not a standard deviation, so it's
It is the standard deviation. The standard deviation is 100.
of the mean
if you look at the sentence, the mean, okay, the mean computed from the sample is 385
Mm-hmm.
and standard deviation is 100. Okay,
But
so
that's
sample is 385 with a standard deviation.
Okay.
Okay, so then what formula you are going to use here? Then you are going to use t-test. You can't use this edge because you don't know population standard deviation. Use t formula. So then put the numbers. 400, standard deviation 100, sample 96, hypothesis mean is 400, alpha is 0.05. Sorry, sample mean 385. Again, what is your conclusion? Yeah, so I know you're confused, so then you draw this. Two tail because it's 1 point, therefore it's 98. This is minus 1.98. So this is H naught acceptance area. So where do you get the critical value? Sorry, T stat. T stat is falling inside minus 1.47. So that means inside means H naught acceptance area. So therefore, do not reject H naught. So that means real state is correct. Okay. Okay, so we did something quite differently. You know this slide, you have all the details. So they have actually used 400 less than 400 as the alternative hypothesis, right? But we use a not equal to. So if they use less than 400, our critical value, you have to use this one tail critical value. Okay, 1.66. Less than means you all have to use your left hand side. Okay, so if you use this one, mu equals 400, other one is HA, mu is less than 400. If that is the case, your distribution, this is your left hand side, right? Less than means left hand side, so it's you use minus 1.661. Okay, so only one side you use because it's left one tail test. So this entire area called H naught acceptance. this is falling into this area, minus 1.47. So you still H naught rejected. Okay. I mean, either you use the diagram or you can use this way. Right? So you got this manually 1.47. So don't reject because minus 1.7 is bigger than minus 1.661. So therefore you don't reject. So there is not enough evidence to say that rent is actually less than 400. Yeah.
I have a question. The alpha is always 5%.
No, it can be any value.
Okay.
But we usually use three values. I mean, yeah, 5%, 2.5%, and 1%.
Okay.
Very good question. Because, I mean, if I do a research, you know, I'll be doing like hundreds of, maybe 100, 200 times of estimation in the computer. So I cannot, you know, change 5%, 1% always. Because it's easy to remember, everyone knows 5% means 1.96. So if you give a statistic, they can compare with 1.96 always. Okay, so that's it. It's like, you know, the body temperature is, you know, is 98 Fahrenheit. If it is 100, you know you have fever. Like that. Okay. Well, you can change it to 0.25. See what happened. Critical value increase. That's all. Yeah. So it's 1% means 0.01. So the critical value increase. So even Z value, there are only three. Either you can have 0.05 or you can have 0.25. So it's 1. I mean 2 per, yeah, 1.96 is critical, and if it is 1%, then it's going to be 2.32. Okay, so if you use different level, so this critical value will bigger. You know, your acceptance region will be little bit bigger. So here, if it is a margin, sometimes, you know, if it is very tiny difference here, you reject. But if you increase from 5% to 1%, so this will expand, and now you actually don't reject. At 5%, you know, you might not reject, but 1% you might reject. That is very difficult to make a decision. I mean, it is very close. So usually, if your calculated value is bigger than 2, you know, this value, bigger than 2, this one, always is safe to say we reject the null. Okay. become 2. So we reject the null. Okay, because most of the time critical values are less than 2. 1.96 OH2. Okay, last question. This one. Try that. Last question. So the last question says that they will go for a lockdown. This is a COVID-19 question. They will go for a lockdown if 3% of the population got COVID. Okay, if they found 3% of the population contracted COVID-19, they will go for a lockdown. Yeah, so how do they do? So they test, they have to test. So they take 1,000 people and test for COVID-19. And they found 32 people got the virus. Then what are you going to do? Going for lockdown or not? Well, you have to do it at 1%. There's no 5%, right? And so this is not a mean value. This is whether they got virus or not. So yes or no. It's called proportion. Okay. So we have type of data. Yes or no data, right? Like male or female, all right? You college or university or working or study, okay? Yes or no, all right? So therefore this is called proportion. Now the assumed value or hypothesis value is 3%, right? They will go for a lockdown if it is more than 3%. So therefore we have this one as bigger than 3%. That's the alternative. And then you have to calculate Z value. Use this formula to calculate this one. And yeah, how do you calculate this? P hat. P hat is the proportion calculated. How much percentage got COVID? Yeah. So P hat is how much is P hat? So P hat is not given here. Out of 32, I mean 1,000 out of 32. That is a proportion. How much? 0.032. That is P hat. And there is something called Q naught. Q naught equals 1 minus P naught. You know there are two possibilities, got COVID or don't have COVID. So therefore Q naught is the probability not having COVID, P naught is probability that having COVID. So therefore 1 minus P naught means 0.03. So that is 97. Yeah, I think in the formula you know now everything. Okay, so 0.32 minus 0.03 square root of this number. So Z statistic is 0.37. Very small Z statistic, so therefore you can't reject. That means at 1% there is not enough evidence to say that the population got more than 3% COVID-19 cases. Okay, so they are not going for a lockdown. Alright, so again, this is the question, right? So they go for a lockdown if more than 3% people got virus, and they got a sample, 1,000 people, they found 32 people COVID positive. And now you have to do the test. So from these numbers you can calculate. Can you calculate P hat? Yeah. You know 32 people got out of 1000, so the proportion is 0.32, right? So that is there. And then you know P naught is the value here, this is P naught, right? So N is 1000, that's there. P naught and Q naught is 1 minus P naught, 0.97. Yeah, and then you go to the next step. Your Z value is 0.37. So according to the decision rule, this is smaller than your critical value, which is 2.33. You don't reject the null. Okay. So how do you do in Excel? Go here, there is a test proportion. So sample proportion how much? 0.32. Sample size 1000. Hypothesized proportion is 0.03. Alpha is 0.01. Yeah, all good. So this one is already there now. 0.37. It's a one tail. 2.33. Okay, so again, if you can't write the conclusion, I said that draw this. Where's your critical value? Mark it 2.33. Okay, so this is this area called what? H naught accept. So you accept on this area. So your Z statistics fall into here 0.37. That means it is actually acceptance area. So therefore, do not reject H naught. Any questions? Yeah, so my advice is yes, you just start redoing all the questions again. Right, now if you don't have any questions, so we can discuss about the assignments. Okay, your assignment, you can go to evidence of learning, data analysis portfolio, open the assignment questions. Yeah. So evidence of learning, data analysis portfolio. Open the question here. Yeah. Okay, so the first question is you need to use data provided in sales Excel, immigration Excel, visa, business. So where do you get the data for the first question? So if you go to your this link and then you get the Excel file. This is your immigration, sales, visa, business, income. Okay, that's the data you should be using for your assignment. So the first question is using data provided in sales, which graph is suitable for that data? So that's your first question. Second one is immigration data, which graph is better? Second one is visa, which data is better? Sorry, which graph is better? So question number D, you have data in the business sheet, so some numbers. So you need to analyze. Either you can decide what graph is. I mean, it doesn't ask directly a graph, but whatever, you need to analyze data and write something about the behavior of data. Question number A, income database is provided. So you need to create a frequency table. You need to decide like how many classes, what is the width. You can't have a very large numbers, you can't have very small numbers. So, decide what is the right amount and explain why. And then you draw histogram. Week 5 we did that. And look at it and say what type of a histogram. It's a normal distribution, symmetric or not. And then question number C, numerical summary measures. What do you mean by numerical summary measures? What do we include? Numerical summary measures. We should include mean, median, mode, all these variance, standard deviation. So these are numerical summary measures. Okay. So question number D, E, F mean that you can't answer those 3 questions yet because we are doing it next week. Question number 3 is A, B, C, D is about hypothesis testing. That's what we discuss. Okay, so if you have any questions, let me know. And yeah.
Can you say again the question D, E, F you don't do?
No, because we haven't discussed, it's week 8.
Yes, but where is it again? Or what is that?
B, C, D.
B, C, D.
Sorry. D, E, F, yes.
D, E, F.
Yeah, you can't answer it now, and you have to wait until next week.
You cannot answer it now?
Yeah, because you can answer if you know it, that's fine. But we haven't discussed that topic yet. You can answer if you know it, you can answer. And the other thing is that okay, so other thing is that I know I know this is quite hard. Last semester and the previous semesters, this is very important. Student have because we collect feedback, So student has written statistics. It's very confusing, very hard, and they have. I think they have told the coordinators that they don't understand anything. Yeah, but actually, when we got your answer script, right? Because you said it's difficult. That means, but your answers are so good. How can it be? How can, if you don't, if you say it's very difficult, and you never ask me, you never ask me how you do it, but you get me very good answers. So the college is asking me how, if they said so difficult, how did they become get a lot of good marks? You know what?
I know why.
Using Excel is very well for them.
Sorry.
They are very good to using Excel. I think.
I mean, if you are good in Excel, then why you say very hard? So you need to know what you're going to. I mean, you know what I said, right? Yeah. I mean, usually yes. So if it's difficult, then students' grade also should be very low. But I know you're going to do very well. Right. Okay. If you have any questions, let me know. So thank you.
Oh, we get just one more question.
Yeah.
So you answer in the Excel?
No, no. Yeah, you do your graphs in Excel. That's a very good question. So very important that you draw your graphs in Excel and copy the graph and paste it under each question. So you don't have to create a new document. You can type your answers underneath each question, and you can submit this document. Okay, because there's no word count, so you don't have to worry about it. You can simply type your answer and submit this. Save it and submit. So all the questions requires you to copy and paste your Excel output.
So Excel and Word.
Huh?
So you answer on the Excel and the Word.
Yeah, I think, okay, this is like this. Suppose you do hypothesis testing. Okay, this one, copy as a picture, that's the best way. And where's the hypothesis testing question? That's it, like that. And suppose you have a, okay, graph. Say if that is your graph, okay. So happy. Copy. Okay, so you think it's a line graph is the best. Copy. That's how you work in Excel. And then you say, okay, you can write something like that. So the line graph is suitable for data because, you know, something like that. Yeah, this one. You can save underneath, save as your name, please put your name and save it as your name and then submit. Okay, so the last thing is your mark attendance.
Thế nào?
Excel report. Một cái câu hỏi Excel evidence of
Ahmed Hazan, no. Nikesh, Jeff, Kehan, Kathy, Soy, Aquila,
Here.
David,
Tiếp.
Eugene here, Shane, Listen, not here, right? Clint, Daniel, Yushi, Poonam is here, Umrafi, Kiera, Trish, Sanjay, Ramona, Wali Singh, Ayman Ali,
Because my class is Thursday.
Charlie Singh,
Oh, wait, have you tell me say your name first?
Oh yeah, he said.
Oh, you have the Excel work thing, right? Like the example 1, 2, and 3, the Excel. What do you mean? Still loading. Still loading. Still loading.
Excel results.
Still loading. Example 1, 2, and 3. Still loading.
no, that's after science.
2 hours.
Yeah.
Be patient. You have the answer for example 1, 2, and maybe snake.
Yeah.
That's one.
Okay, any of this question? This
Mình
one
còn
is
bao nhiêu ngày nữa để nộp cái này? My Excel was like broke.
Oh, okay.
So if you look at this question, you need a sample. So this is a sample of 96.
Because I think I've hybrid my Excel.
They
I
take
think it's broke.
96
Mình còn 17 ngày nữa mà, đúng
Yeah,
không?
what is the range? What is the range?
Yeah,
What
I
is the
know
range?
Excel.
See you, see you.
So you need a sample, so simple and that one. So if you look at this one, it is also sample of 4. So that means they check 4 samples. That's simple.
So I cannot send.
Tai nghe tôi đâu rồi?
Okay.
Yes. À đây, tai nghe tôi đây. Còn 17 ngày nhé. Trước mắt mình còn 2 ngày nữa để nộp cái kia kìa.
Okay.
21 còn lại là 17 ngày
You
nữa.
look at proportion.
Có chi sinh.
Proportion. This is actually
Yo, Kiara.
CU.
I know you missed class, but you can do it, man.
There's,
You can catch up.
two chances, like people have COVID or people don't have COVID, right? So that means 2 chances. It's like when you toss a coin, you can